Morning students, good evening, good afternoon when you are going to watch this video. So I am very happy to meet you through video. I hope all are fine and at the present situation you are going to use more effectively on distant learning. Myself, Vijay Kumar, I am going to discuss about electricity, class 10, chapter number 12. Let us start with electric charge. What is meant by electric charge? It is a fundamental property of any matter like mass, length. The same way the electric charge also defined is the fundamental property. There are two kinds of charges. One is positive, another one is negative. It is a scalar quantity. It is measured in coulomb. Whenever we are using the unit as a scientist, the symbol should be capital. By convention, the charge on electron is negative and the proton it is positive. What will be the magnitude of the charge for electron as well as proton? The magnitude is 1.6 into 10 power minus 19 coulomb. What are the source of getting electric charges? One of the methods is frictional electricity. So to understand frictional electricity, let us understand about the structure of the atom. Suppose you have the atom. It is having equal number of positive, equal number of negative. So it is what? Neutral. Where the positive charge? Inside the nucleus. So it is not so easy to remove positive charge. So what is the possibility? Electrons are revolving around the nucleus. So with the minimum energy, we are able to remove the electron. That is the method we are going to use in frictional electricity. For example, you are taken the two bodies A and B. When these two are rubbed against each other, few electrons are transferred to another body. For example, A to B. Why not B to A? Because where the electrons are loosely bound, it will lose the electron. So here in A, the electrons are loosely bound. For example, 5 electrons are transferred. Another example I am giving for you, real example, glass and silk. When these two are rubbed against each other, the glass is losing the electron. For example, here 10 electrons are transferred to silk. Then what will be the charge on glass? Automatically the glass becomes positive. Because what happened previously? Neutral. Two bodies. Now what happened? Electrons are transferred. So automatically what happened? It is cancelled. So you have in this case plus 2e. In this case minus 2e. The same way here. Suppose the 10 electrons are transferred. The glass gets plus 10e and the silk gets minus 10e. So then what is meant by positive? What is meant by negative? Very simple. Let us explain in terms of electron only. The loss of electron is nothing but positive. Gain of electron is nothing but negative charge. So how to define positive negative? With respect to electron only, because only electron can be transferred during friction process. I think you got very clear idea about what is electric charge, what are the kinds of electric charge, and how we are getting the electric charge. One misconception may be that whenever we talk about electricity, it is nothing but electric charges. But in real life, what is electricity? What we talk, it is the current electricity. So let us discuss about what are the basic properties of electric charges. Very simple concept. The first point you see, like charges repel. Suppose positive, negative repel each other. Unlike charges attract, positive and negative attract each other. These are very simple property. The very important is these three. Conserve. The total charge in a system remains constant. How the total charge remains constant? You already read chemical reaction. So the reactant side, how much charge you calculate. The product side, how much charge you calculate. The total remains same. Here also look at it in glass and silk. Before rubbing, glass and silk both are neutral. What we are expecting after rubbing also, the total charge must be 0, that is neutral. Yes. Plus 10e minus 10e, the total value will be 0. So the charge is conserved. The next one is additive in nature. How to add it? Because you have plus and minus. So the sum should be algebraic sum. Suppose you have only positive number, simply we say sum. You have positive and negative. You have to do algebraic sum. You add the value with the sign. Suppose the quantity having vector direction, then you have to add with the direction. That's all. So sum, algebraic sum, vector sum. Only magnitude sum. Plus and minus, then algebraic sum. With the direction, vector sum. The last one is very important is quantized. Energy is quantized. What is the meaning? You can have the energy only in discrete value. You can have one value, 10x, 5x. The same way, the electric charge on any body can have integral multiples of elementary charge. What is elementary charge we are taking? Minimum charge, charge of electron, E. So, what is the value of N? 1, 2, 3, 4, etc. So, in this case, whether suppose they are telling, suppose 1 coulomb of charge. So, how many electrons are required? You can calculate, no? Suppose you put Q equal to 1 coulomb. So, what is the value of N you find out? Q 1 coulomb, E 1.6 in 10 power minus 19 coulomb. Coulomb will give answer. What is N you find out? In this case, the N will be 6.25 into 10 power 18. Imagine. To get 1 coulomb of charge, how many electrons should be added or removed? 6.25 into 10 power 18. That's why the coulomb is very big unit. That's why we go for smaller units. What are the smaller units? Already written coulomb. So what are the smaller units? Millicoulomb. Millicoulomb is nothing but 10 power minus 3 coulomb. Microcoulomb 10 power minus 6 coulomb. I think you got to understand about why we are going for millicoulomb and microcoulomb. Because 1 coulomb itself very large number. So using this you can understand whether anybody can have the particular charge or not. How to do that? Put the value of charge, find out N. N is the natural number, yes, allowed. If it is not a natural number, it is invalid. Okay? Let us talk about the classification of material, because that is a basic for current electricity. One is the conductors, another one is insulators. What is meant by conductors? Conductors allow the passage of electricity. The electricity means electric charges are allowed to flow through the body. It is nothing but conductors. Look at the examples. Human body is a very good electrical conduction takes place. Suppose by mistake any insulation, anything is removed, by mistake if you touch it, will get electric shock. What is it? Electric shock is nothing but what? Electric charges flow through our body. Metals, for example, copper, aluminium, silver, all the things. I think the silver is the best conductor. The third one, mercury, it is a liquid, it is a very good conductor. The second classification is insulators. Insulators we have glass, rubber, plastic, etc. For example, you have the electrical wire. Inside what we have? Metal conductor. Outside what we have? Insulation. It may be a rubber or plastic for safety purpose. So we are using both the conductors and the insulator. The gas is also poor conductor of electricity. It is an insulator. You might have read I think discharge of electricity through gases, but the gas will not conduct electricity at a normal pressure. Okay, for your additional information I am giving, what is the atmospheric pressure? 760 millimeter of mercury. Under what pressure it can conduct electricity? 0.01 millimeter of mercury. Almost what you say, it is equivalent of vacuum. That's why the gas is insulator over conductor. Let's discuss about electric potential difference. In real life already you are knowing, suppose you have the two containers A, B having different amount of liquid. You can see that their levels also different. Suppose when these two are connected by the pipe, now what will happen? How the liquid will flow? Yes, the liquid will flow from A to B because the A is at a higher level, B is at a lower level because of that difference in pressure. So the difference in pressure is responsible for flow of liquid. The another example, suppose you take the two bodies A and B at different temperatures. How the heat will flow? Suppose now these two are placed in contact. Already I given an example. Temperature at A is greater than at B. So what will happen? Automatically heat flows from A to B. Yes, in winter season what is happening? Where the temperature is more, our body temperature is more as compared to surrounding. That's why we lose the heat. In summer, yes, now we are gaining the heat because our temperature is less as compared to surrounding. That's why we feel hot. So to flow the liquid, the difference in pressure is required. To flow the heat, difference in temperature is required. Similarly, to flow the electric charges, the potential difference is required. It is must. Then which one provides potential difference? It is nothing but cell or battery. All are familiar with the cell or battery? This is nothing but cell. This is a positive, this is negative terminal. Two terminals are there. The positive, it is at a higher potential, negative is at the lower potential. So once the potential difference is developed, the electric charges start flowing. So which is responsible for electrical conduction? Potential difference. So how to define potential difference? Even though it is written V, but it is nothing but potential between two different points. For example, A to B. So electric potential difference equal to work done per unit charge. What we are doing? We are moving the charge from one point to another point. For that we have to do the work, that is work done. So how to define potential difference, electric potential difference? It is defined as amount of work done per unit charge in moving it from one point to another point. To move the charge from one point to another point, how much work we are doing, it is nothing but potential difference. Look at the formula again, the another form, how it is measured in volt, scalar quantity. Yes. Now, how to measure? It is using voltmeter. Other instrument, just I will show you the symbol. The voltmeter, it is connected in parallel in the circuit. Why parallel, series, all the things we are going to discuss in the next video. Now work done equal to Q into V. So work done, or I can say energy. It's very important concept here, because whatever electricity units we are consuming, whatever electrical energy we are consuming, it doesn't mean that we are consuming the number of charges, consuming number of electrons. No, for that we are not paying electricity. We are paying to do work done to move the electron, to move the charges. That's why it is nothing but energy. I am giving a simple example. Suppose one point the electric potential is 100 volt, the other point 150 volt. Now I want to move the charge 5 coulomb from A to B. How much work I have to do? Potential difference how much? 150 minus 100, 50. Which charge you are moving? 5 coulomb. Example I have taken, easy calculation. So how much energy you are spending? 250 joule. Who is spending the energy here? Electric cell. In the electric cell, how the energy is stored? In the form of chemical. That is called chemical energy. So the chemical energy is consumed. I think you got very clear idea about electric potential difference. The basic formula, work done upon charge, that is measured in volt. The instrument we are using, voltmeter. How to connect voltmeter? In parallel. Okay. So to flow the liquid we want what you call pressure difference. To flow the heat we want temperature difference. The same way we want potential difference to flow the electric charges. Let us go on to electric current. I think now this is an actual chapter. You know, we talk about electricity is nothing but current electricity. So what is electric current? It is a rate of flow of electric charges. In the particular time, how much electric charge, for particular time interval, how much electric charge is moving in the particular cross section, that is called electric current. How we are measuring? Q by T. Now you want to calculate in terms of number of charges. Ne upon T. You can use it both the formula for numerical purpose. How the electric current is measured? In ampere. What is the instrument we are going to use for that? Ammeter. Ammeter. How to connect ammeter in the circuit? Series. Try to understand once again. So the rate of flow of electric charge is nothing but electric current. It is measured in ampere, scalar quantity. Which instrument we are using? Ammeter to measure the current. In the circuit, how to connect the ammeter? In series combination. Series or parallel, already I told you, we are going to discuss it later in the other videos. Why series parallel? Look at it. Now more explanation I am going to give about electric current. Suppose I have one metallic wire, for example copper wire. Conductors, which is responsible for electrical conduction? Free electrons. Okay, free charges. How the electrons are moving? Look at it. These are the electrons. Electrons are moving. How they are moving? Randomly. When they move randomly, suppose one electron is going left, the other electron is right. What happens? The current due to both will be cancelled. What is the net flow of electric charge? Zero. What is the net current? Zero. Then how to get the electric current? What is required to flow the electric charge? Yes, potential difference. Which one provides potential difference? Electric cell or battery? Nothing. Cell is nothing but only one. If you are using signal, that is called electric cell. The combination of cell is nothing but battery. Okay, both are providing potential difference. Look at it here. Now all the electrons are attracted towards positive terminal of the battery. So now there is a net flow. Yes. Net flow. Net flow. Not equal to zero. It has some value. Yes. When the net flow is not equal to zero, definitely the net current is not equal to zero. So then what is the direction of current? It is by convention that this is the direction of current. How the electrons are moving? How the electrons are moving? This is the direction of electron. So the conventional current direction is opposite to flow of electron or along the direction in which positive charges would move. Okay, so you got what is about the electric current, how the electrical conduction takes place in the metal. The last topic in this video, electric circuit and components. What is meant by electric circuit? It is a continuous and closed path of an electric current. It is nothing but electric circuit. For example, if you want electric circuit, it is nothing but electric circuit. Okay, because the path is closed. This one. Okay, this is. So I am showing some electrical components with the symbol, the purpose. Let us look at the chart. Yes. First one you see, it is nothing but cell. So one is positive, another one is negative terminal. The second one is combination of cell. What I told already, combination of cell, it is nothing but battery. It provides more voltage, more current. The third one, what you are seeing, it is the key. Now no dot inside, so automatically it is get open. Plug in, we say. The dot is the fourth one. Now the circuit is on. The fifth one you see the wire with the connection where the dot is there, the points are connected. All the three wires are connected. Next one you have fifth one. Here no connection, no joint. Last one electric bulb. Electric bulb either you put like that or another one. No problem. Next resistance. Resistance, it looks like a speed breaker because speed breaker also opposes. That point we will discuss more detail. Next one is variable resistance, or another symbol is nothing but rheostat. The last two, one is ammeter, another one is voltmeter. Ammeter, voltmeter and the battery all are having the polarity, positive, negative. It should be specified in the circuit. But in resistor, there is no polarity. Now, let us summarize what are the things we discussed in the video. What are the things we discussed in this video? So, let us see the concept of electric charge. It is a fundamental property of any matter. It has two types, positive and negative. Loss of electron is nothing but positive, gain of electron is nothing but negative. It is a scalar quantity. Very important thing, two property already I told. One is it is conserved, another one it is quantized. So what is the basic formula we learned here? Q equal to plus or minus Ne. Plus or minus Ne. Next let us see the next category, that is categories of different materials. The main classification as per our syllabus we discuss about the conductors and insulators. Conductors allow the electric charge, insulator does not allow. You should understand very well, for electrical conduction both are required. Yes, in case of electrical wire, inside you have the metal, it is nothing but conductors. Outside you have the insulation, it may be the plastic, it may be the rubber and other things. The third concept, which one we are discussing about, the potential difference. Here we say electric potential, but it is nothing but potential difference. Because even when you talk about potential, one point we take at infinity. That is a concept that is little complicated, that you will learn in higher classes. So in this case, to flow the electric charge, which is responsible? Potential difference. Which one provides potential difference? Yes, cell or battery. How the electric charges flow? From higher potential to lower potential. How to remember? Fluid flow, heat flow. Yes, the liquid will flow from higher level to lower level, difference in pressure. Heat flows from higher temperature to lower temperature, difference in temperature. So what is the basic formula? Work upon charge. Work is nothing but what? Energy. For electricity, why we are paying the electricity bill? How much work is done? Who is doing the work? Electric cell. The chemical energy stored in the cell is spinning. Okay. the last one we discuss about electric current. Electric current. What is the basic formula? Rate of flow of electric charge. It is nothing but Q by T. Q, amount of charge flowing, T, time interval. For particular time taken, how much charges are crossing in the particular cross section of a conductor. So the basic formula Q by T. The Q you can express in terms of number of charges, that is NE. What is E? Elementary charge. Charge of electron or proton. And then we discussed about the electric circuit. Electric circuit is nothing but what? Continuous and closed path of an electric current. Continuous and closed path of electric current. And then we discussed about the different electrical components. Students, just go through the concept, go through the video. Whenever you are sitting, you take the notebook, pen and start working. Note the important points so that your focus will be there and your concentration will be there and you will get the real benefit also. So one thing I want to tell you, physics, it's not difficult. Physics is nothing but enjoy. You can enjoy with the physics. Only thing, how the current is required continuous for, the same way you need continuity in the subject. So without skipping any concept, any topic, let us go through all the points step by step. Let us feel the concept, let us understand and enjoy happily.